Thanks for coming, everyone. I know it's pretty late in the day, and I appreciate that you made it, and I hope we'll have fun. So yeah, the idea of this talk, and I think that's the way the other ones in this track have been, is we'll talk about the technology from a pretty high level, just try and get you guys kind of involved in understanding the basic concepts. And then there's actually a lab. So if you can hang around, it's a hands-on lab. We actually have like paid resources for you in Cloud Foundry existing, so it's not something you have to download. It's something you'll access online. It happens to be Pivotal Web Services, which is one of our partners that has an online service. So I hope you can learn something today and hang around. This is actually a pretty view from really close to the Linux Foundation offices. If you ever guys get out to San Francisco, we have offices in the Presidio, and you should come visit us. Okay, why don't I start with a couple introductions so we know kind of the lay of the land here. So I work for the Cloud Foundry Foundation. We're a relatively small team within the Linux Foundation. So we're a nonprofit or a not-for-profit 501c6, which is in some complex tax structure way different than 501c3. But basically means we are the people that support the community and the code. So we deal with any compliance issues or legal issues or IP issues around the code, mostly trying to bring people in so they're interested in contributing to the code and helping those contributors get recognized and feel like they have what they need to do, to keep building Cloud Foundry itself as effectively as possible. I've been with the Cloud Foundry Foundation for 2.5 years. I happen to have a PhD in computer science, and I spent a bunch of time at Oracle and VMware before this. So Cloud Foundry actually was started at VMware when I was there, and I kind of knew the people, but I actually had never pushed an application on Cloud Foundry until I ended up at the foundation. My focus, I had done some certification at VMware, and when I joined the foundation, it was clear we needed to think about certifying developers. So there's actually a good certification exam out there that's been out there for a couple years now, which I helped build, and that's been a big focus, and then a training program around that. And I'll give you a little plug on that at the end if you're interested in getting certified in Cloud Foundry. So today, again, trying to keep things relatively high level to fit in with the other things you might have learned in this track. We'll give you an introduction to what Platform as a Service is, how it fits with other AAS type things, what's kind of unique about Cloud Foundry in that space. And then we'll delve into specifically what it's like to develop applications with Cloud Foundry, what are the kind of value props there, how it fits into the cloud native kind of ecosystem and space. We'll talk specifically about services in the Cloud Foundry kind of nomenclature, means probably data services like databases, routes, kind of HTTP routes that you'll use. And then we'll talk about multi-cloud and heterogeneous platforms with CF as the ability. Cloud Foundry, one of its main abilities is portability. So it's a high-level abstraction, but it works on essentially any infrastructure underneath it. And we'll talk more about that as we go. And feel free to raise your hands and ask questions. Okay, just kind of trying to set the context here. If you're a developer not that long ago, or some of us are developers in the situation today, traditionally before kind of the cloud and virtualization revolutions that have happened, you had to think of a lot of things besides just writing some code, really. So let's say your real goal was to write a really cool application that solves some interesting business problem for your community. But you'd also have to think, well, do I have to build some security into there? What are the risks in this software I'm writing? Is there a database I need to attach to it? How do I get that database? What are the operating systems I need to use? Is there a virtualization layer I care about? What physical servers will I use? What external storage? What networking solutions? What data center should I locate those things in? Those of us who were writing applications before all the nice cloud technology started coming into our world, we had to think about a lot of things that distracted us from writing that software. A few years ago, infrastructure as a service, so essentially hardware in virtual machine form factors sitting out on the net, solved a lot of those problems, right? At least we didn't have to think about virtualization, where the physical boxes were, any of the bottom things. Typically, we would still have to say, oh, me as an application developer, I have to still think about security and authorization for my users. If I need a database, I might need to talk to IT or open a ticket and say I need a database of this style with this size. I need to decide what operating system I like to work in and which operating system is going to be most useful for the customers. So again, a lot of things that you need to think about outside of just, hey, I know what application I want to write. I want to start coding and get that thing done. So we like to think that platform as a service allows us to really focus on the critical question, right? So you're not going to, so Cloud Foundry and any platform as a service essentially is going to take care of security layer. It's going to allocate things like databases in a self-service way without any intervention. It's going to decide what operating system components are needed, and it will supply those to the system. Similarly, you don't need to worry about kind of what's the underlying resources, as they're all kind of abstracted away from you. So the idea is just really focus on writing the application, and the rest should be just done for you. So it provides a high-level abstraction that I meant. Sometimes, as I mentioned, sometimes people use the word opinion. So it's an opinionated platform in the sense that we think we have ideas about how to optimize developer productivity, and we're going to build a platform where those decisions are kind of built into the platform. So if you're actually aligning with those assumptions, it should solve a lot of work. If you say, actually, I don't really like the way Cloud Foundry does security or the way Cloud Foundry allocates databases, I want to do that separately, then that's going to be a lot of work for you. So if you follow the opinions of the platform, you will get things done. If you're trying to do things differently, then you might struggle a bit. Again, the real goal is increasing the agility of developers. And I'll talk more about kind of the iterative assumptions we make in terms of software development. But another benefit is kind of reducing the churn between silos. So again, talking about the previous picture where on the far left, traditionally the application developer would write the code, he'd hand off to a testing team, the testing team would do some testing, he'd hand off to the operations team, say we're ready to put it into production. All these different silos that would do handoff separately. The idea of Cloud Foundry is to empower the developer to solve a lot of those problems by themselves as quickly as possible. So Cloud Foundry assumes a kind of DevOps environment and benefits best from a DevOps environment. I guess you could use it in a standalone way, but it'd be very unusual. So let's talk a little bit about the kind of virtual cycle that people talk about with DevOps. So I usually start here where someone might be a product manager saying, hey, here's the changes that we think our customers want in the code. So the team will get together, maybe build a Scrum or even extreme development where they're pairing up, for example. Hopefully make some quick changes to solve these problems because maybe it's a relatively small change because, again, we're kind of in an iterative model here. They're going to start doing testing there. That's probably continuous integration, continuous deployment. So automated stuff that happens as soon as they check that stuff into GitHub, gets deployed somewhere where you start getting feedback from customers, whether they're internal or external. Eventually it makes it to production where you're monitoring both the resources consumed, as well as ideally talking to customers quickly after they start touching the new product and get feedback quickly, and then come back to the product manager saying, hey, that was great, we improved that product a little bit, but customers are still wondering, could we put a save button on screen 3, whatever it is. You're, again, trying to make as quick operations there and to improve the product as you can and release as quickly as you can. So Cloud Foundry in the DevOps context, again, we assume that we're doing as much automation as we can along the lines of DevOps, but only some parts of that are actually Cloud Foundry itself. So CI/CD, I think we all assume, is important in DevOps and would be closely connected to Cloud Foundry. There actually is a separate Cloud Foundry CI/CD system called Concourse, but we work well with Jenkins also and all other CI/CD tool sets. But there happens to be a separate one there that a lot of the folks use. But again, just trying to make that DevOps circle work as quickly as possible. Again, as I mentioned earlier, CF developers tend to be less dependent on other teams. A lot of the traditional stuff of testing, staging, production deployment, and operations may be things, depending on the way you want to organize your IT, that the developer can either help with or actually entirely own. And our goal in general is lots of small iterative improvements in products versus the large releases that we all kind of traditionally did a long time ago. So this has been a really fun conference for me. I've done a lot of Cloud Foundry specific conferences, and coming to an open source summit that's kind of general in terms of open source has been fun. And one of the main things is just seeing people try and put Cloud Foundry into their kind of bigger picture of open source projects, and certainly Kubernetes and container orchestration is one of the really shiny objects out there that we're all kind of interested in. So I've got a lot of questions on how Kubernetes and platform as a service differ. So I'll try and in this talk kind of maybe reference a little bit of Kubernetes because it's been mentioned a lot during this week and give you a little bit of compare and contrast, I think. Before I should jump into that, I might want to say also, so Kubernetes lives within the Cloud Native Compute Foundation, another Linux Foundation project. So we're kind of brother projects, sister projects. So we both like each other, and it's interesting to differentiate, but I think Kubernetes and Cloud Foundry get along well, and I'll talk more about how we're making specific integrations between the two product sets. So generally, I talked about levels of abstraction earlier. I think of container orchestration usually is working on a lower level abstraction, at least Kubernetes in particular, maybe I should speak to. There's more control, but on the other hand, a little bit more complexity. And so again, so stick on the more control and hence more complexity. There's a lot of knobs to tweak in Kubernetes. Often those knobs end up in YAML files somewhere. And you can control essentially everything with Kubernetes, which is really cool, but also it's a fair bit of work depending if you really want the simplest way to deploy an application quickly. So platform as a service on the other side is generally a higher level abstraction. We like to think it gives you more productivity, but you definitely have less control. We make assumptions in the platform about a lot of things like security, database services, whatever. And if, again, as I mentioned earlier, if you don't like those assumptions, it's going to be a bit of a struggle for you. If you like them, hopefully you can get work done quicker. I make the point here also that we kind of manage containers. Internally, we actually use containers. They're not necessarily Docker containers. So we do appreciate the value of containers as a kind of deployment vehicle, but they're actually under the covers, whereas users bring their own containers, generally Docker containers in a Kubernetes world. And we manage build packs, dependency, security, and I'll talk more about those items now. Here's a little tweet thread that I thought was kind of interesting. So Kelsey Hightower is from Google. He's a kind of thought leader in the Kubernetes space. And a while ago, I actually don't know the date of the original tweet, he said, Kubernetes is the platform for building platforms. It's a better place to start, not the end game. And Matt had worked in Cloud Foundry for quite a while. I guess he says 4 years here. This is from a few weeks ago. And has done Kubernetes work for maybe a year, because there is a lot of crossover between these communities, saying, I'll just read the last part, raw Kubernetes has the primitives for building platforms. It's not a tool to deploy apps. So I think that's a good way to think about it. Is Kubernetes, again, gives you tons of control in terms of all of the things you might want to control in an IT system, but it isn't necessarily the easiest way to just get out there and deploy an application. And if you stay around for the lab today, you'll get a chance to kind of experience that simplicity. So let's dive into a little bit more in detail of developing applications. And yeah, in the Cloud Foundry world, we have a haiku, which is kind of a big deal for us. So if you haven't played with Cloud Foundry, you're going to hear this haiku every time you talk about Cloud Foundry, which is kind of fun. Here's my source code. Run it on the cloud for me. I do not care how. So first of all, I just want to give a shout out that it's cool that we have a haiku. Not everyone does. But also, again, kind of reinforcing that feeling of let loose of the details and focus on writing your code, and you will get stuff done. And you won't necessarily have to worry about those details as long as you kind of roughly align with our philosophy of how those details look. So the kind of first construct to understand in Cloud Foundry is the application push. So CF push is essentially, it assumes something called build packs. It actually came from I guess it's also considered a platform as a service, Heroku, which was kind of an early version of something similar to Cloud Foundry. So the idea is you take a bunch of source code, you're kind of ready to create an executable out of that source code. You put it in a directory, you say CF push. Now, Cloud Foundry will look in that directory and say, oh, I see a gem file, so this must be Ruby, or I see a war file, so I'm going to assume it's Java. So it'll try and do detection of what that source code is and what are all the things it needs to bring to the table in order to execute that source code. You as a user don't have to think about any of those problems, assuming it works. So we have build packs. Each one essentially supports a language and goes from source code towards a runnable, executable piece of code. And it works with, by default, it has built-in build packs for, 10 of the languages that are most common. If you want to bring your own language or your own technique, you can actually create your own build packs. So you can explicitly say, use this build pack because it's something you've never seen before, or use the default one and figure it out, and it probably will be able to do it, unless you're using a pretty obscure language. So that's, I guess I've talked about the automated detection. It'll figure out, what do I need to create from this source code, create an executable that I can run at that point. So the user provides the app, the build pack provides all the dependencies, and we create what we call a droplet, which is essentially a container. So that's we do use containers, but they're kind of under the covers in the sense the user doesn't necessarily ever see that container. So the three components again. Okay, app bits in the middle, it's not that well called out, but so you bring the application, the build pack will identify what it needs. We bring OS components that has a basic file system. This is essentially talking about inside the container now, as well as whatever kernel you need. So these are kind of the things that you would expect to find in a normal container along with the code that you brought. It's just that we provide that from the Cloud Foundry side, the actual system itself will bring those things, and that has some benefits to it. Okay, there's a little more detail on this. I guess it's more or less what I just said. But so the platform actually brings kind of what you need for runtime to execute the code, as well as the OS image and container image that you'll need. There's some value to that. Now, there's a little bit of a security concern, depending on your tolerance for security issues, of just Docker bringing code that the platform doesn't necessarily own, right? So for example, the Heartbleed vulnerability, when that showed up, if people had Docker images that had that built in, then that would be a risk every time you ran that Docker image. We bring the OS images relatively dynamically. So again, you do a CF push, we'll build a container internal to Cloud Foundry and start executing that container. So when we had to deal with the Heartbleed issue, we were able to just change the root FS and the stem cell, which is then the OS components that make up that container, and in that way we were able to eliminate the Heartbleed from existing Cloud Foundry instances in kind of real time. So with 2 commands, I think it was over minutes, we were able to get rid of Heartbleed in a given Cloud Foundry instance, which is a great example of why that's handy to kind of own that piece. Okay, so let's talk a little bit about more practical stuff. It's based on a command line interface, like most systems you'll see. RESTful APIs, calling the cloud controller over HTTP, kind of typical. Let's talk a little bit about how we break down resources in Cloud Foundry. So any given CF installation will have a set of organizations. You'll be assigned, as a user, you'll be assigned at least one organization, and within those are spaces. So organizations tend to be shared across a work group. Spaces can be individual spaces just for you, or maybe a couple of people share them. But again, kind of fully isolated in the sense that if he deploys an application and calls it my app, and she over here in this other space deploys my app, you won't see each other, which is one reason why I tend to do kind of development at the space level, so you don't have to worry about any kind of overlapping naming conventions or whatever else. So anyway, that's it. So yeah, multi-tenancy in Cloud Foundry, a little bit different than the Kubernetes model. We generally have a lot of tenants share a given CF instance. So CF instances, consider them relatively big, and you could use one for your entire company, or you could have a small number, but usually you wouldn't bother spinning up a CF instance for an individual or a small team. As I mentioned earlier, orgs are typically shared by a team of users. So Cloud Foundry, as I was mentioning before, so a typical kind of active instance might be over 40 VMs. So relatively big. When I first arrived, I was like, why is our system so big? And my boss was like, dude, you don't get all those services for free. If you want all the security and services that we have, then you have to pay some VMs. So that's why, whereas I find Kubernetes a little more dynamic. You might spin up your own kube just to try something out. It does have namespaces, but tends to be a little bit less in terms of kind of strict isolation like we tend to do in the Cloud Foundry world. And it's certainly a lot easier to spin up a kube cluster than it is to install Cloud Foundry. So I mentioned earlier, so you do a CF push, we take a build pack, mix it with your application code, and essentially create a container. At that point, our task is not that different than other container orchestrations tasks, though it's not necessarily visible to the user. So we're going to take that droplet, as I mentioned, which is just another kind of term for a container, and we have computational cells spread across virtual machines. Diego is the mechanism, it's the machinery underneath the covers that does the placement. So it does a lot of what Kubernetes does, but it's just slightly different kind of use case. It's built specifically for the Cloud Foundry use case. So again, virtual machines running cells, which are essentially computational engines, and placing droplets on them. Again, we assume things are scalable, so you may have 10 instances of one application, 5 of another, and Kubernetes will make relatively informed decisions about where to place those droplets on cells. So routes is another thing where we, again, kind of show the opinionated nature of Cloud Foundry. So when we say route, we mean essentially a URL, right? So whatever, timsapps.cfapps.io would be a typical full URL. So when you push an application, by default, we will give you a route. And that's an external route, and you can be anywhere in the world and access that application. So you'll get a domain, as you will see if you stay around for the demo. You'll get a domain that you're kind of limited to. That's physically what's available in terms of that CF instance. And then you can make choices within reason about what the URL you want to route to your application. They can be fully specified. You can say it has to live on slack.cloudfoundry.org. But again, it's globally visible, so there's a lot of potential for naming conflicts in terms of URL. So there's random routes where you get 2 random words stuck in there in your URL. Like in this case, it's unridiculed checkup. Somehow they're always slightly funny to me. I don't know, I kind of enjoy the random routes. But anyway, we'll see those later if you do the lab with us. There's a load balancer that just appears when needed. So if you have multiple instances, it will load balance just randomly across them, evenly distributed. It's not a very sophisticated load balancer, but it comes for free whenever you need it. And routes have a life cycle of their own. One thing that we try and do separation of concerns as much as possible. So any components that are really different and can be separated, should be separated. So routes appear, they're attached to a certain application. You can take it off that application and attach it to another application, or you can delete the route. And there's use cases where that's actually really handy. We talked about blue-green routing earlier as a way to kind of test new applications. So you can have an old application and a new application sharing the same route in some percentage so that maybe 10% of the time you hit that route and you get the new application and you get to see it and get some early feedback without shutting down the old application yet. So real quick, a little more detail on the client. So we'll ask for a certain URL. We'll go to the load balancer to spread across multiple CF routers, because again, CF instances are relatively big and redundant, so there's multiple CF routers. And then they will look at the URL and figure out, okay, that points at an application running in this droplet or in this container within this cell. So again, the kind of computational area in terms of application runtime that Diego runs, the router knows where all those things live and helps you find it. So security in general is something that the platform takes a lot of control over, and user authentication and authorization is a big part of that. So it's a role-based access, as you would expect. You can create a user, you allocate roles to that, and it implements OAuth 2.0 standard. So it's pretty much what everyone does. It answers the questions, who are you and what can you access, which is, again, a role-based access. It's pretty much what you need. I'm sure there's some people who find it insufficient, add more security concerns, feel like there's more security concerns they have to solve, but most people just use standard UAA and kind of built-in primitives to think about security and user access. Okay, so some of the things we talked about briefly, CF push experience using build packs is really the kind of user-facing difference between something like Cloud Foundry and other platforms. Diego under the cover is essentially doing what's similar to what Kubernetes does in terms of managing those containers and routing them to the appropriate place such that they can be executed. And then routes by default having access to everything outside your universe. So kind of getting ingress by default, which is kind of a different model than Kubernetes. So cloud native is another kind of area that we definitely fit within well. So let's talk about a little bit about general cloud native and then how we fit through it. So we talked a little bit about the DevOps automation piece. Continuous delivery is certainly assumed for everything in cloud native. As I said, we use Concourse typically, but we also use Jenkins. I don't know if these are really required for cloud native. When I think of cloud native, I think of applications that are designed to run well in the cloud. And for me, that's generally, so microservices is kind of a functional component of that. And we'll talk a little bit more about that. But basically breaking things into components that solve unique problems and focusing on that separation of concerns that I mentioned earlier. So you're not kind of blurring the picture in terms of what this application does. It should do one thing and one thing well. Containers, again, I think of as an implementation technology that's kind of useful for cloud native, but to me it doesn't necessarily cause an application to be cloud native. It's just kind of a useful primitive. So probably when you're thinking about cloud native apps, again, it comes down to kind of monolithic applications versus microservices. I think that a lot of us who were developing code a while ago are very familiar with someone taking over someone's gigantic monolithic application and changing some, the 10th subroutine slightly and having everything else break. So there's a lot of issues that come up with code that tries to solve all problems in essentially one simple application, and they're a lot harder to maintain, and they kind of break that separation of concern problem. So you definitely want to, so we believe strongly that any Cloud Foundry application should start with what are the kind of micro pieces that are atomic, what's the smallest piece we can break off that solve a specific problem, and can we reuse them? I think of whatever, getting credit card information or creating a new user account or this kind of thing are typical kind of reusable components that really are not necessarily tied to any particular application. So the more you can focus on microservices, the more you can reuse code, separate your concerns, and hopefully improve code quality. Stateless and scalable. So this is an important assumption, I think, for cloud native, and probably, in my mind, more important than the other ones on the previous slide, is we assume that to make things scalable as you want to in cloud computing, you really need to be stateless. So what that means is the application itself is not managing state. That's external to the application. So there is a database in essentially some form of database or data storage associated with almost every interesting application. And that should be a separate entity where the state is kept. And then the application is ephemeral. Sometimes the application dies and gets restarted. Sometimes you scale from one instance of the application to 20 instances. The scaling right down to 0 and up, again, should be independent of where your data is and how valuable your data is and whether you have a risk of losing your data. So applications should be stateless and scalable, and we'll talk a little bit more about our model of separating out the state from the application. And if you want to get deep into cloud native, 12factor.net is kind of the tomb on that. I find it a little hard to get the intuition of the 12 factors, not to mention that 12 is a big number, and I tend to get a little bogged down on it. But it is kind of definitely the next level of depth if you want to get deep on cloud native and get past the kind of higher level that we're talking about today. So let's talk about services. So services, unfortunately, is a very overloaded term. There's a million things that services mean in different contexts. So technically, the word is services we use in Cloud Foundry. I think of it as either backing services or data services. It doesn't necessarily have to be a data service, and we'll talk a little bit what the characteristics are. But they're external components that provide value to your application that you can bind with your application. And certainly, MySQL databases and Redis databases are, big, very frequent services that people adopt for their applications. So you probably can't see this at all. If you do CF Marketplace, it'll give you a list of a bunch of services. It starts out with Greenplum, MongoDB, App Autoscaler, Blaze Meter. This happens to be, I think, Pivotal Web Services. So these are all services, and these are, the plans that you can use. So it's often as simple as small, medium, and large, or if it's a database, it might be size, for example. So you, as a user, don't need any IT intervention. Thanks. This is the only time I got a code snippet, so it's not too important. So you, as a user, don't need any IT intervention. You can say, yeah, I need a MongoDB database of, in this case, you only have one plan, a standard size, and I'm going to bind it with my application without calling anyone from IT and just make it happen. So our services are kept external to the consuming apps. I mentioned that our apps are stateless, but there is state, and it's living in these external services. It's all self-service provisioned. The broker is something, so if you want a service in the marketplace, you create a Cloud Foundry broker. The broker is actually based on an API that's called the open source broker API, and has gone outside, bigger than Cloud Foundry in the sense Kubernetes also uses it. Open source broker API is used in a lot of different open source projects. So it's an interesting way to expose services, backing services, data services that computational components might need, and now it's used. You can actually share a database, for example, MongoDB database. It can be accessed from a Kubernetes cluster, and the same database can be accessed from a Cloud Foundry cluster. And the way you would do that is by defining an open service broker. I'll tell you a little bit about more what it does. But to get your and to get aligned in that marketplace results, you need a broker. This is mostly an administrative task, so it requires kind of admin agreement, as you might think, because you don't necessarily want strange databases appearing and people using them without knowing something about it. On the other hand, you can create one space scope now. It's a relatively new feature just for you and your team, and then you don't need to go through kind of administration privileges to do that. And a service has a life cycle, again, independent of other things. You create a service instance, which is a create service command, but you're talking about one instance of, for example, a database. You bind that instance to an application, and then you can unbind it and delete it when you're done. So if we look a little bit about what the service broker itself does, so it's an entity, it's essentially an application out here. It can provide the information needed for the catalog, which is what you see when you do see this service marketplace. This is the user somewhere over here going through the Cloud Controller API. And the Cloud Controller, it'll allow you to provision. It'll allow you to bind to an application. You can allow it to unbind and deprovision. And each of these commands, so it creates a service, then it binds to the application. Then you can unbind it and delete it later. The way it actually does it is it updates credentials and the URL of that service into a variable called vcap services, which has some implementation. It has some impact that it's a static variable, and we'll see that if we in the lab. Yep. You'd actually delete the service you have and then go get another one. So in terms of, so it'll scale up, most databases will just use as much space as you want within a limit, and that limit comes from the original marketplace plan. So if I go back to that, this ugly graphic, so each of these has, for example, if we look at one that looks like a database, I don't know, let's just pick whatever. They'll often have, okay, here's one that size, Memcache Cloud, 100 megabyte size, 200 megabyte size, 500, et cetera. And they're actually, these can be paid services too. They can be externally supported. It could be a third company that has said, hey, would you like to use my services in your marketplace? And they can get actually paid for it. The asterisk here means it's a paid plan, and this is a free plan. Does that answer your question? Yeah, so you can scale up to the max there, and if you really need more, you got to go get a new one, and you might have to pay more for it. Okay, so multi-cloud and multi-platform is an important part of Cloud Foundry's world, and I'll talk about more what I mean by this, but we think it's very important that Cloud Foundry is entirely portable, independent of what resources you can want to run it on. So you can run on AWS, you can run on GCP, you can run on physical hardware locally, or run on OpenStack locally, or VMware is one of the early platforms, obviously. And whichever that is, the interface will be identical. The code will be identical except one component of it, and I'll tell you about that. But so that's an important part of kind of Cloud Foundry's story, is portability across deployments. The way we do that, we have something called BOSH, which is essentially our deployment management method. So it's been around for a while, but Cloud Foundry is probably the most common use case for developing it. So you get a BOSH release. It specifies it needs certain VMs to support that, and it could be Cloud Foundry or something else. We actually can deploy Cloud Foundry with Kubernetes too, but most people do BOSH. It's actually possible to deploy with Kubernetes. I'll talk a little bit about more integration with Kubernetes in a little bit. But the way we do deployments with BOSH and avoid any kind of dependence on the underlying platform is something called the cloud provider interface. So I think of it as a shim between the deployment methodology and the resources that are underneath it. So Cloud Foundry with BOSH deploys in the same way on all platforms, except that when it says, I need a new VM, BOSH asks the CPI to translate that into whether that's AWS speak, GCP speak, physical hardware speak, OpenStack speak. So there's a CPI for every provider. And every time you need a VM, it'll ask for a VM via that CPI, via the local, whatever that infrastructure requires. So the actual code base is identical in every instance of Cloud Foundry, but the underlying resources come from a provider via the CPI. Just a note on BOSH also is BOSH deploys and then it does day 2 operations also. And what that means is it doesn't just give you a bunch of VMs and then forget about it. It gives you a bunch of VMs with specific processes on them and then it monitors them. So if you lose a VM, it'll restart that VM. If you lose a process, it'll restart that process. So we like to think BOSH, it deploys and that's cool stuff it does, and then it supports kind of the operational piece of the platform also. So this is a picture of kind of how BOSH and the CPIs work. So basically, you're doing a BOSH deploy of Cloud Foundry. You go to the BOSH CLI, you say deploy Cloud Foundry. It'll make calls for every VM it needs via the CPI for whatever IaaS layer it could be. Again, this is VMware, AWS, or OpenStack listed here, though there's a bigger list. And whenever it creates a VM, it'll hand it to the Cloud Foundry environment with an agent on it so that they can monitor that VM and make sure it doesn't go away. So these are some of the things I've said before, I guess. Cloud Foundry has no knowledge or interest in the underlying IaaS, which is good. It's very portable. And again, it allows for kind of true multi-cloud use cases, which generally I think are just a good idea. I think no matter who you love, AWS, GCP, or OpenStack stuff locally, it's nice to feel like you're not stuck on any vendor on no matter who you work with. So the other thing we have is a certification program, which is pretty common, I think, in open source projects, to make sure that the things that are released as Cloud Foundry are identical in the sense you can use them. So some of these guys are happen to be 8 currently that some of them are actually distributions. So SUSE has a new distribution. I don't think they have an online service, so they might be thinking about it. I actually don't know that piece. Pivotal has an online service, so you can go there and say, I'm going to pay for a subscription, and they give you, by the way, they give you free credits in the beginning, as a lot of these places do. IBM also has a similar kind of online service. Swiss Commons an online service. And then some of these are more distributions. Actually, Pivotal has a distribution also. So that's more. Here's a software, we'll help you install it on your local hardware or on AWS if you prefer. But they don't. But the assumption is you're running it yourself versus they're running it. So we have kind of broad. We have a spread across people that sell distributions and people deploy it locally or publicly hosted versions of Cloud Foundry. But all of them are essentially equivalent in the sense that certification essentially shows that you can run the same applications on all of these things. The only variation is ever the services. As I mentioned, services are kind of a third-party thing in our world. So if you go from Pivotal to IBM, you may see different services, for example. Okay, so let's talk a little bit about container runtime, and this is Kubernetes specifically. So again, I mentioned there is a lot of interest in how these two platforms work together. What we've done to kind of try and bootstrap that conversation is actually you can have a Cloud Foundry instance that also includes Kubernetes. So in terms of kind of rebranding, it's called the container runtime is the Kubernetes piece, and the application runtime is the traditional Diego actually manages the containers, the traditional build pack model that we were talking about earlier. So BOSH can deploy both of these. They both can use the Open Service Broker API to manage services, as I mentioned before. And then you as a developer, and I think whether it's managed by Cloud Foundry or BOSH or totally separately, I do feel like this is probably where we will be in the immediate future and maybe for a while is developers can say, hey, do I think this would work better on Kubernetes, or would this work better on a build pack model like Cloud Foundry? And so if someone gives you an application that's already all containerized and you just want to run it, maybe the container runtime or Kubernetes is the easiest way to do that. If you're building something from scratch and focused on microservices and doesn't necessarily want to iterate through Docker containers, the application runtime provides a lot of value there. So these two environments are kind of converging in some form, and this is the one form that might be. So I guess, yeah, it doesn't say that much different. It allows different deployment models for different applications, but it's all sharing the same infrastructure. Again, BOSH can be used in this case to deploy both the Cloud Foundry pieces and the container orchestration pieces, and then you get that kind of day two operational support of managing your VMs. We do focus a lot on interaction with the ecosystem, and I think that's one of the big kind of focuses of Cloud Foundry community in general, whether that's CPIs to keep a list of infrastructure providers that we can access without totally transparently without affecting the interface at all, or working with service brokers and external parties, as well as explicit integrations to different open source projects. Here's another fact that might be kind of useful. So we tend to be kind of in the big enterprise space. So I think a lot of people coming out of college now might be running into Kubernetes use cases and playing with Kubernetes more than Cloud Foundry. But then if you get a job at a big company like Volkswagen is one of our big user communities, or Allstate Insurance or Home Depot, they may say, okay, we use Cloud Foundry for a lot of our work. So I think we're a little less kind of visible to the average consumer out there, or even the average kind of IT person, unless you work in bigger companies, because that's where we tend to play. So I mentioned we kind of have been working with Kubernetes a fair bit. Container runtime I mentioned. There's also an effort, I also mentioned Diego as our kind of application runtime engine is a lot like Kubernetes. There's an effort where IBM and other engineers are kind of looking at, could you replace Diego with Kubernetes? There's BOSH CPI for Kubernetes, so you could say BOSH will, whenever it deploys a VM, it'll actually build a pod with Kubernetes and use that for the VM. It's another interesting project. And then another kind of integration effort, Istio and Envoy, I believe they're Cloud Native Computing Foundation projects, so they're kind of aligned with Kubernetes, but not Kubernetes. They're useful. Istio is a service mesh concept, so you can connect any service with any user. I talked a little bit about blue-green deploys. There's a lot of interesting kind of more sophisticated ways you can change the routing across application versions, for example, using Istio. And Envoy is a proxy that allows you to just do authentication real accurately on a container. So these are kind of actively being looked at as potential ways that both Cloud Foundry and Kubernetes could work together, but also just projects that kind of originally came from the Kubernetes space, but are adding value in the Cloud Foundry space now. These are the focuses. I mean, we want developer velocity is really our focus, and we think we can do that through innovation and interoperability. So quick summary, we assume DevOps, cloud native, scalable, secure, deployable, all those good things. And we interact a lot with other OSS communities and feel like those integrations give us a lot of value. So kind of more practical stuff. Again, I mentioned that I kind of focus on training and certification, so glad to talk through this stuff. There's a Cloud Foundry developers course, which is kind of 3 or 4 days, which is designed to get you kind of pretty deep, so to the point you might be able to take that on as a career choice for you at that point. There's also a 1-day, or it was originally 1 day if it was instructor-led, but now it's all e-learning, so it could be arbitrarily long, but it's a free edX MOOC, massive online, what's the third one? Course. Open, yeah, thank you. Open online course, right. So, and edX is a nice shorter course. We also do training course at our CF Summits. Our next one is in Basel in October, so come to that if you want to get deep. And then the certification program I mentioned before, it's a relatively hard exam, and I think that's good because employers recognize it as if you pass the certification, you're probably ready to do some work in Cloud Foundry, at least will be able to ramp up quickly. So it's performance-based. It's actually a hands-on exam. It's 3 hours. You're actually tasked with, do this job activity that you would do in a typical Cloud Foundry environment, and you sit there at the CLI and you get it done. So it's a pretty interesting exam. I think all this gives you a relatively clear path towards, broadening your career to include potential Cloud Foundry activities. So that's it for this piece. So at this point, I think we'll jump into labs, which will be a little challenging for me to get to you. The first step will be... OK, so let me give you the high level on the lab, and then we'll kind of drill down into detail. Probably the easiest is that if we all try and type in this URL into our local machines, and I hope this isn't too annoying for you. But probably, let's see, let me see if I can blow this up to something more reasonable. So raise your hand if you want to do the lab. I think it's going to be fun if you, OK. I think it'll be interesting. You can follow along and watch it, or you can do it. But there are resources allocated. So, we're actually going to pay a little bit of money for you guys to do this. If that makes it more interesting, I don't know. So probably the easiest is to type in this tiny URL, tinyurl.com/ and I can read it off if you want, but hopefully you guys can see it. Y7BDMS5L. And then you guys will see the same thing as me, and we won't have to share too much. Yeah, it's a Google Doc. Do you see it? Does anyone get it? OK, cool. OK, I think, there's a lot of different ways to do labs, and sometimes they end up being more demos than labs if we have to. But I think it's worth just doing this and trying to step through it. So I guess what I'd ask is that, so GitHub accounts, it's open source conference. Good to have if you don't have it. Do that. Installing Git on your local machine. Maybe you've already done that again because we're at an open source conference. So in which case, the meatiest piece is installing the CF CLI. And I didn't try and copy it all into here, but this link will give you pretty good descriptions. So my gut is that we should, I don't know, the first two steps, do people need GitHub IDs? Do you guys have everyone on Git and that stuff's there? OK. I'm guessing these two are probably easier. But I guess I would suggest maybe we spend 5 minutes doing these, and then we can kind of start the lab. That makes sense? And then I can walk around if you have any problems or questions. OK. Yeah, so now we're in this shared org that we all share, and then I picked a space that's just for me, and then I'm by myself. So should I just demo this then? Because it seems like it's kind of hard to get people on, and we can all learn something anyway. OK, so there's a command called CF apps, which tells you every app that's running there. There's no apps running because this is my own space. Again, so spaces are generally used as kind of full isolation like that. So I already copied this repo here. So this happens to be a Ruby on Rails app, which I don't know that much about, to be honest. I'm not a Ruby guy. But there's a gem file here. So Cloud Foundry will, if you try and push this application, it'll look at that gem file and say, oh, this is a Ruby application. I need to bring a Ruby build pack. I already moved this manifest, which is a later part in the... Bear with me for a second. I'm trying to return to the state we're supposed to be at when you start. OK, so it's going to do that. The other thing it's going to do is find a manifest file. We didn't talk about manifest files. They're pretty small in Cloud Foundry. I know in Kubernetes you get a lot of YAML going on. Cloud Foundry tends to be small. So look at this. This is a manifest file. It tells you the name of the application that you're pushing. So it's going to push whatever code it finds, and then it's going to assign the application name as CF Rails. It tells you the memory that you're going to use for it, the number of instances, which happens to be 1, and whether you want to build a random route that it says true. Random route is, again, you could say mycoolapp.cloudfoundry.org, But again, that's a global URL. So if it's ever been created before, you'll have a conflict. So that's why we use random routes. So particularly in the case where there's a manifest file, literally, I'm in the right directory with all this code here that the developer says, yes, I want to push that. So I go cf push once I've done my login. And hopefully cool stuff happens. So at this point, it looks at the manifest first and kind of repeats what it knows, what it learned from the manifest. It's already created a random route for us, cfrails-exhausted porcupine, I think it was. See, that was cool. I don't know how the random routes route is so cool, but. And then, so it figured out it's a Ruby app. It's bringing in Ruby build pack version 1.7.22. And this is all stuff. I won't be able to tell you all this stuff. I know it's doing smart stuff to eliminate the dependencies or to collect the dependencies it needs to be able to build an executable object out of that code. But it's relatively verbose, which is cool. And it takes a couple of minutes. So this is, at this point, it's staging it. We call staging it is building the droplet, or essentially the container. And then running it, starting it, will be, depending on how many instances you ask for, saying to Diego is our container orchestration engine, here's the droplet I built. Where can we run it? And it'll find a spot and start it. So they're kind of two steps. You can just compile, you can just prepare it, you can just stage it, without starting it, or you can start it. Those warnings, I don't know what they're about, but they're not causing problems. Info, writing, something. I'm not sure. Yeah, it takes a minute or two, but I guess that's not, I guess it's about the same as if you're compiling it locally. Outside of latency, I guess. Okay, so it's done. So it's pushed the application. We can see that this is the instance number. There's one instance numbered 0. It uses 512 meg, all the stuff that was in the manifest file. Yeah.
When you say instance, would that be a different VM instance, or in that space?
Good question. I'm talking about the application instance now. So you can say, I want 5 instances of the application, and Diego will figure out what cells to run them on. So that's all under the cover stuff, but they'll be numbered 1 through 5.
That space.
Yes, all in this space. And you will have, by default, you get a load balancer that just routes across them. And we'll be able to look at that in a second, actually. Yeah, there's the route. So the application name and the exhausted porcupine happens to be the random route that it came up with. Okay, so CF apps, did we do that yet? We did it before, nothing showed up. It shows up just like more or less as we asked. So let's go ahead and scale this, shall we? So we can say CF scale. Okay, there's good help. Let's start using that. So most stuff you need to do, you can do with, it's kind of self-documenting, the CLI is. So there is a command called cfscale. If we look at the parameter cfscale app name, the number of instances, you could change memory or disk size in that time also. So cfscale, it's called cfrails is our app. And we can say minus instances, let's go with 4 and see if that, I don't know the memory constraints here. Did it work already? CF apps. Okay, so now if we look at instances, it says 4 out of 4. Okay, so it all seems relatively vague. I mean, there is an application running. We can see it has 4 instances, but what can we actually learn from that? So we grab the URL, and again, this is the part where my kids get intrigued. Like, you could take that URL in China or in Peru and use that URL, and it will point at the application you just started. And this is the application UI. It's very simple. I mean, there's nothing much to it. It's meant to just be a kind of a test app that tells you what's going on. The probably one interesting thing, though, if you're wondering about it, so now we have 4 instances. They're all sharing the same URL. So how does that work? So if we refresh this baby, let's see if that instance number changes.
Where is the instance number?
Instance index. It just changed from 3 to 2.
I didn't get your command for scaling, sorry.
So I scaled it up. CF,
What was the command?
CF scale, then minus I in the number of instances you want. Sorry, CF scale, app name, CF Rails, then minus I. It's actually in that sheet also. So now we have 4 instances, and you can't really tell except that it changes once in a while. And what you can tell is, I mean, it actually, I think it's kind of random. It's a simple load balancer. It does the right thing. It spreads the load across the 4, but I don't think there's any real logic to it. But you can see that it shows up there. Okay. So I think in the lab, I suggest that we delete this app and then do it again without the manifest. So the manifest file, I don't want it to be too magic. So I'm going to move the manifest file, which tells you the parameters to push it with, to an old manifest. It only looks for the name manifest, so if it's not called that, it ignores it. And then really what that thing is doing is just specifying a few parameters, right? So we can push it again, CF push, CF Rails, and I can do all these things, minus M512 meg, minus I. Let's do 2 this time for a change, and then dash random route. So just showing that the manifest is not magic. And I know sometimes you get YAML files like, trust me, ignore those 200 lines of YAML, it's nothing. But we don't need YAML necessarily to push an application. It just, I got rid of the manifest file. I actually moved it to an old manifest file just so that we can do this push without a manifest file. So now we're doing everything that, we're doing the entire push is 1 line on the CLI just to show that manifest files are not super important. Some people don't believe they should be used. I don't know, there's some philosophical reasons. I don't get the nuance behind that conversation, but I tend to use CLI if I can because it's nice to know what you're doing. But if you want to do something repeatedly, obviously, it's nice to have code. So yeah, we can push with a manifest file, we can push without, we can scale it, we can add memory, we can do all any of that stuff. Let's see what else I'm going to show you. Let's attach services next. We'll look at the data services that are available. I kind of feel like bailing on this, but we'll get another random route. Okay, so there's our 2 instances that started, and now we're CF Rails fearless links.cfapps.io. Okay, so let's look at that in.
So you could provide your own domain, I guess, right?
The domain is harder, right? Because those are owned. I mean, you have to kind of own them. So an online service will typically have a few domains. You can look at them, CF domains. So with Pivotal Web Service, you can call it, it can end up at cfapps.io, or it could be cf-tcpapps.io, apps.internal. Now, I know we have a cloudfoundry.org we can deploy to, so you can have your own private domains too. But they all have to be like DNS visible, so they're like real things. It's just like if you want a URL for your website. You kind of have to own that domain, and then you can share it across all the people who are deploying from your Cloud Foundry instances. Okay, so let's look at the marketplace. So again, if you have a cool database and you want to make it accessible to Pivotal Web Service user, which happens to be the online service using marketplace, then you create a broker, assuming the administrators are going to do this, help you with this, and you'll end up in this marketplace. And we can pick one of these and attach it. This application is kind of a demo app, so it'll show what services are attached to it, so we'll be able to see if it's actually binding the service. But it doesn't necessarily, it doesn't actually make much use of it, of course. As you know, if you're actually writing code to utilize, I don't know what, Redis database, it's a little different than what you do with MySQL or whatever else. So for example, there's a Redis database here. So the service is called Redis Cloud. These are the sizes. I mentioned earlier the stars are ones you'd pay for, and I don't know the prices. I forget how it works, but I know I made these spaces so that we couldn't access those. I forget how you find out the price. Maybe just when you get a bill. I think that's when you find out. So instead of calling the IT buddy and creating a help desk ticket, we say create service. It's actually creating a service instance, which I find that sometimes a little misleading. But again, the best way to do things in Cloud Foundry is take a guess at what you're going to do, and then say --help and read again. Okay, so create service, service, plan, service instance. So service instance is the name I make up. The other two are coming out of this this catalog. CF create service. And it was Redis Cloud, all one word, I believe. And I wanted that 30 megabyte one. And I'm going to say Tim's Redis. See if I did that right. So it's essentially allocating 30 meg. I don't know if it's creating a whole separate instance of the database or just somehow isolating that for users. And then, so now we have a separate instance of an application sitting by itself, and we have a separate instance of a Redis database, so we need to bind those two. Bind service --help. So to bind the service, we need that my app name and my service name. That's easy. And our app is CF Rails. So the service eventually will allow you to do queries against it or do whatever the service does. So initially they are kind of entities, but as you attach it, it will do real work, right? So the binding process actually passes credentials. So at that point in application code, you're going to access that database the way you would with any database. Now you have credentials and then start using it. So you can write SQL code or whatever you want to do to use that stuff. So before you use it, it looks like any old app, but yeah, you actually use it, it actually becomes something useful. Tim's Redis, I think I called it that. Is that all I have to do? I think so. Okay.
That's okay.
Okay, so now if we look at this app, it will, do you think it shows it or not? Oh, I have to get the Linux thing, whatever it's called. I gotta get the new URL because we moved it. Okay, so we go back to this app. It thinks there's no services bound, even though from the command line it looks like there is a service that we bound. The reason it is that when it binds the service, it essentially puts credentials into a variable that's available to the application, but it doesn't inject them. So if the cell is already created, so there's already an application running somewhere, it doesn't go back and check that variable. It already has a copy of that variable. So we basically have to restart the application so that it looks and sees, oh, I have new variables for this VCAP services thing. So we go CF restart, CF Rails. I think that's all we have to do. And so again, restarting is a lot cheaper than restaging. So we don't need to upload all the bits and the build pack and compile them or whatever you need to do to make that a runtime element. We just start the container again, essentially, and it uptakes any apps, any variables that it doesn't know about.
You have to run a, like a, what do you call it, a, like a, 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 a,
Yeah, you can specify ports and all that stuff. It can be anywhere. I mean, obviously there's some constraints within firewalls and stuff. It needs to be available locally. But again, it could be a different data center. It can be anything that you have a URL and credentials for, just like a normal database. Like,
When you bind it, you mention the whole thing.
yeah, so it instantiates variables in something called vcap services that include the URL. The main things, yeah, I think I had a slide on this at some point. The main things are the, sorry if this is worth doing or not, is the URL for this service, the, sorry, being a little clumsy with this slide deck now. The URL and the credentials for the application. That's the main thing. And with that, you can do anything, right? That's what you expect for a database. And so they're in this data structure. And so anyway, so when I refresh this app after we restaged it, I restarted it, it sees the service here. So it knows that there's a Redis cloud service attached to it with its name Tim's Redis and its 30 megabyte plan. We don't do anything interesting with it in this application, as you can tell, but what else is fun? So I'll do one more thing, and then we can kind of wrap up. I think we're probably done at that point.
You're showing us the command line, right?
Yes.
I could log into the console, I guess.
UI. There is one, but it's actually it's company specific. The open source doesn't have a well. There's a new project for an open source, but by default, the CLI is what you do to almost do everything. And then different vendors sometimes will build consoles on top of them. So so Pivotal happens to have one, but it's Pivotal specific. It shows most of the same stuff. And they can choose to do administrative functions through UI only, and sometimes that's the place where you have to go to the UI is sometimes they'll say, hey, you can't create new orgs without going to the UI. I think that might be true with Pivotal Web Services. I don't know. Anyway, I probably will just leave it there unless there's, I mean, what else, is there anything else interesting? I think it gives you a basic feeling of how to push an application, how to create services, how to bind services, something about routes. Any questions or anything else we want to drill down on here?
So you mentioned that you have to restart your app in order to get the credentials in from the database side. So in this case, your app should be stateless, because if you're restarting it, then you're going to lose the state. So I guess best practice would be to keep it stateless.
Right. Yeah. Yeah, it's stateless except for variables it knows about. Yeah, so it'll hold on to those variables, and it kind of gives a glimpse of those variables, I think, when we restart them. So, yeah, is that still stateless?
In this case, that was a major change to the app, which is changing your database, right? Database is usually used to keep state, for example. For example, you manage your state there or somewhere else.
Session state is
kept away.
Right.
Redis.
Yeah, I guess it's session state versus like data state, huh? Is it? So there's variables that are external to the application, but it can look at them, but it only gets updates to them if you restart it. Does that make sense? Yeah.
It just seems like you have to be careful about that.
Yeah, that's true. Well, so I mean, and I think, and the goal of being stateless is mostly about scalability, right? So I guess, and being ephemerality, if that's a word, right? So in theory, the app could die, it could restart it, and it would still work. So if it died and restarted it and sees the same variable, in the session, then I guess it's okay. But yeah, there's probably a lot of PhD computer science topics on that that I don't know anything about. But I think the very simplistic way of like, can it scale? Because I know, if you directly bind one instance of an application, let's say you build an application that has a database embedded in it, and then you try and scale it, that won't work, right? That if you can't write to multiple versions of the same database and expect it to somehow come all together. So that's where I think of course, that is a problem with a stateless app that doesn't scale. And if you can scale it and make it go away and it still works, I think of it as stateless. But it's kind of a functional definition, like does it achieve your goals? Did you have a question?
was about to ask, so if you deploy this Cloud Foundry on AWS, for example, just can you talk a little bit about the scaling or the deployment to, how do you manage, like based on your app footprint, how much should I deploy Cloud Foundry? You said 40 VMs or, just.
It'll,
Yeah.
it does those things auto. So I know with AWS you can set limits in terms of how much you want something to scale, but Cloud Foundry will try and scale automatically. And so that's Diego will always need to have, so Diego's the one that says, I have an application ready to run, so it's a droplet in our term or container in other more generic terms, and I need to run these many instances. It'll keep doing that. Eventually it'll get to a utilization figure. User administrator can change that utilization figure, and it'll say, oh, I need more cells. I need more places to run stuff, because all my cells are over 30% full, or whatever the number is, and then it'll say, I need more VMs, and it'll actually ask Bosch, and Bosch will say, okay, I know how to talk to the underlying resources. I need another VM. It happens to be AWS, so I'll use the CPI to get it, whatever, but it'll say, I need another VM. So it'll keep scaling as you use load.
So the administrator will specify the utilization of the app. For example, my app, I want it to be max 70% or 80%.
Yeah, it's a little more nuanced because it's actually Diego doing it, but there's a bunch of administrative parameters like that. The administrator can say, scale up, scale down at these variable, at these
rules,
points.
policies.
Yeah. And if you want to say don't scale at all, then I guess you would start having contention problems and performance problems and stuff. I guess the bad news of being fully automated is sometimes you don't know how much you're spending on AWS resources, which is a real problem.
You could put a limit maybe on the
Yeah,
scale or something.
I mean, that's a problem we all run into, right? I mean,
Yeah, it's a good problem.
I guess.
Thank you.
Yeah. We did hands-on labs in our summit in Boston, and I shut down all the VMs afterwards because we were actually paying money for them. Oh, they're on Google Compute Resources, yeah. I shut down all the VMs. But Google has some model by which, like, even if you shut them down, they still hold state somehow, and they charge us, like, so like for the week after the conference, we spent like $500 on Google resources. That's like, but anyway, so it's not that uncommon in cloud computing. Things get expensive and you don't know why. Okay, anything else? Or? Cool, well, thanks a lot for hanging around, guys. I appreciate it. That was a fun session, and appreciate it. Hope you learned something. Thank you. Thanks a lot.
Yeah, I'd like to thank Tim very much for this very last thing. He's holding out to the end. This is our eighth session in CL this week. This is the first time we've run CL, and we hope you've really enjoyed it. Again, there's a survey on the website. If you could fill it out, we'd really appreciate that. But we've spanned the whole gamut from bare metal all the way up through to platform as a service with Cloud Foundry. I hope everyone's learned something, and as far as we know, we're going to be doing this again next year in San Diego when we do this again. So thank you very much.
Cool. Thanks a lot. That was fun.